Welcome, everybody. Good morning, good afternoon, good evening, wherever you are. Happy to have you all here. Today we have another great presentation. It's a webinar by Lorenzo Hidalgo. He's going to be talking about DynamoDB and the common mistakes and how to optimize its use. I've definitely used DynamoDB a lot and always curious to find the mistakes I've made and the mistakes I currently have in production to fix them. So without further ado, I have here Lorenzo. Let me pop you into the stage. Welcome, Lorenzo. How are you doing?
Hey, thanks, Andres. Welcome, everyone. Really good on my side. How about you, Andres?
I'm doing great. Happy to have you here.
Perfect. You set the bar really high with stating it was gonna be a good webinar. Let's hope I can at least achieve that good level.
I have no doubt, Lorenzo. So I'll let you get on with your presentation. I'll pop up your screen and we'll get it going. Thanks for joining us.
Perfect. Okay, so the slides are up. I hope everyone is seeing it. Today's presentation, as Andres already mentioned, will be about DynamoDB, common mistakes, and how to optimize its use. So to give a little bit of introduction or motivation for this talk, it's basically a rant, a rant speak webinar of all the different mistakes I've seen during the past years of people making and thinking that it was the good way to implement DynamoDB. On today's webinar, I'm only going to cover from the dev perspective. So data modeling, single table design, everything else. This is more of a architectural or more high level topic where you can probably read a lot of good blogs out there, especially from Alex Debris. But today we're focusing only on its use from a developer perspective. So to give a little intro to myself, who am I? I'm Lorenzo Hidalgo. I studied computer engineering and then did a master in IT management. I'm currently a staff software engineer at Serverless Guru and also community builder for Serverless, my first year. The agenda for today, as I already mentioned a little bit, it will be about DynamoDB. So first topic, DynamoDB 101, or what DynamoDB is. We will then cover condition expressions. What are they and how to use them? A little bit about pagination and also a little bit about batch operations on DynamoDB. Just as a heads up, I have a few questions during the slides. I would really love for people to interact in the comments and to motivate people to actually interact. I also have a few AWS credits to give as a reward for people that interact the most. Also, feel free to drop the questions anytime in the chat. I'm sure Andres will help me out finding all those questions and answering them at the appropriate time. So, starting DynamoDB general description for, I hope everyone here has already read a little bit about DynamoDB or already played with it, but it's not as common as I would like. So I also prepared just a general description. So DynamoDB, what is actually DynamoDB? It's a managed NoSQL database by AWS, which means that it's serverless. If you configure it as a serverless service, you can also provision it, but it's managed by AWS and it's NoSQL. So no Postgres, no MySQL, no MariaDB, etc. It's NoSQL and ideally serverless, and it's designed to handle large volumes of data with low latency. High availability and automatic scalability. This is an issue normally when you work with SQL or RDS instances, for example. You need to handle scalability and also the availability. The same, this is, as mentioned, a serverless service, so it's handled directly by AWS. Consistent millisecond performance. supports flexible data models. So this is the first step where we see a really big difference on DynamoDB comparing them to other databases, for example, SQL. SQL doesn't have a flexible data model. It's predefined tables with rows and columns. With DynamoDB, you can store data almost as you like. And the last part would be global security and replication. AWS already managed that. It's serverless service. So they encrypt everything and have the replication across multiple regions. So you don't need to worry about availability, and you can even create global tables. So it will almost always be up there. When talking about common mistakes with DynamoDB, it's usually an issue of how developers approach interacting with the database, because most of us, or at least myself, and probably most of the ones listening to this webinar, have been told or learned only SQL databases, so relational databases, and just a little bit or just covered a few hours of NoSQL databases. And most errors comes from that lack of knowledge about how NoSQL databases work and are supposed to be used. Here I have the key differences on SQL and NoSQL databases that I'd like to mention, or at least I would like everyone here to have them in mind the next time they interact with DynamoDB. The first one is data models. What do I mean by data models is what type of data you are expected or you can actually store on on the different databases. On SQL, it's usually only for relational data, so tables with rows and columns. With NoSQL, depending on the database that you end up using, the NoSQL database that you end up using, you can almost store anything, meaning you can store documents or key values. What I like to think, or how I like to imagine it to make it easier and more understandable how DynamoDB works, is you can think of it as a really big folder with a lot of different documents, meaning that you only have access to the name, which would be the primary and sorting key. And SQL, don't hate on me. We're speaking about databases, so I like to compare SQL to an Excel file where you have the table with all rows and columns. I know Excel is not a database. I don't recommend it to be used as one, but it's a really good comparison for people to understand the difference between SQL, Excel, or NoSQL, which would be a folder with a lot of documents inside. Schema. Here comes one of the biggest benefits and also headaches from NoSQL is in SQL databases, you have a fixed schema and you need to define it beforehand, meaning that before you start using your new database, you'll actually need to define it or create it and create all the different tables with a specific fixed schema, meaning you'll need to tell each row will have these columns with these names, these attributes, these are mandatory and these are optional. With NoSQL and DynamoDB, for example, there is nothing like that. The schema for DynamoDB or NoSQL databases is flexible and dynamic. The only thing that has to be consistent across all documents in a single table in NoSQL is the primary key and the sorting key. The rest could every single document be different from each other, meaning that one document could have a schema and another one could have a totally different one. And here comes one of the first issues of you can't really rely on the schema on DynamoDB, depending on how you have developed it on your side. How to access it is in SQL. You have the SQL query language. You can use it almost identical in every single SQL database. For NoSQL, it's very different. For every NoSQL database, you have a system-specific querying language, for example, for DynamoDB, or what we're going to see in the examples today, it will be the AWS SDK for JavaScript. Scalability, SQL is vertical, meaning that every single time you want to make your database more performant, you need to load it on a more performant machine or EC2 instance or computer. With NoSQL, it's horizontal, meaning that you can just add a new machine, but this is handled everything by AWS Direct. And data consistency. Please, please, please. This is one of the most important parts of the talk, or where most of the issues come, is data consistency. SQL does actually provide data consistency with ACID, so atomicity, consistency, isolation, and durability. DynamoDB or NoSQL databases don't provide that type of consistency. They only provide eventual consistency, and this is done in order to improve availability and performance. Okay? So from all the differences that I just mentioned, the more important ones to take into consideration is data models. NoSQL is relational. NoSQL is documents or key values. Data consistency. SQL can have or provide data consistency, and NoSQL databases won't be able to provide it. They will only provide eventual consistency. So now, and the first question for the audience, for everyone looking at or watching the stream, I'd like to know what DynamoDB operations you already know or you have used. Let's see if someone can mention a few ones, and just as a little recap for those that joined a little bit late, we will be giving away a few AWS credits for those that interact more in the chat. Let's give it a few seconds to see if any comment comes in. Otherwise, I'll just move on to the next section. Okay. I think there's also a little delay on the stream. So here comes a lot of perfect. So we have get items, for example, or query. I love the query, and I love that there hasn't come. Oh, yeah, Andres, I was about to say, oh, yes, we didn't get any scan, but we got it. And I also got the yak. So yeah, let's speak about scan later. But perfect. Oh, David, that's the first time I've seen someone talking about batch get item. We'll talk a little bit about it later, but happy to see anyone else apart than me, David and Akisanya, using batch get item. So perfect. I know that at least a little bit of the audience has already worked with DynamoDB or has a little bit of knowledge. So let's start seeing the first differences between SQL and non-SQL. So with a put item example, I think put item didn't, yeah, Akisanya also mentioned put item, but let's compare the put item with SQL. On SQL, we would have that insert into, where we would mention the table name, the column names that we want to add, and then the values for each one. And with DynamoDB, we'll just send a put command like this, where we send the item. We have the primary key. In this case, we don't have any sorting key, and then all the different attributes and values that we want to store. With an update item on SQL, we have the update table name set the columns to be updated, and the where clause to explain where we want actually to update something. With DynamoDB, it's fairly similar, where we have the update command, the table name, the key, so primary key and sorting key to identify the document to be updated, then the update expression and expression attributes and names to know what we want to be updated, and then the return values. From SQL to DynamoDB, there's a big difference here. Does anyone know the difference, or why I think, or why I have this slide open where we know DynamoDB will work differently or interact differently than SQL. What does DynamoDB, or if we had to translate this ones to SQL, what would that be? It would be something like this. DynamoDB, by default, will just overwrite anything. So, meaning that put command, if there's already an item with its primary key, DynamoDB by default will just overwrite it. And the other way around, on the update command, if DynamoDB doesn't find any document with this key here, it will just create a new one. Okay, so totally different than SQL. With the insert into with SQL, if a row with the primary key already exists, it will throw you an error. And update on DynamoDB, on SQL, it will return you the amount of rows that were updated. If there's no row matching the key, then it won't do anything. Not like DynamoDB, where it will just insert the item. So we could say that DynamoDB by default acts as an insert into with on-duplicate key update, meaning that it will overwrite or insert what it would be called upsert. And here is where we face the first issues or the first problems with people implementing DynamoDB. What happens if you have an update command like this, where you're only setting the updated add attribute? There's a really simple example, but if we would only update the updated add attribute or only set this attribute, downstream, we would expect that PK or document called item2 to have more information, more attributes, not only updated add. And DynamoDB will create just one new document with this attribute and return a success when it shouldn't be a success because there was no document called item2. First problem. Or similar to put command. If we don't want to overwrite data and we use put command like this, we'll end up facing some issues because our data will be overwritten or our data will be corrupted and the error will end up downstream with update commands like this. So what do we need to do is, really good comment, Akisanya. That's a very good comment. I include condition expression, and that's exactly what we're going to talk about now. Is what we need to do is to add conditional expressions. And now I hope that at least one of the parts about condition expressions you don't use already or that you can learn from it. But at the end of the talk, there will be a QR code. Please scan that QR code and send me a message on LinkedIn or via mail. And there's some credits going your way for AWS due to that really good comment. So, condition expressions. What do we need to do in order for DynamoDB to not overwrite our existing documents if the attribute already exists? Is something like this. Condition expression attribute not exists. This means that when we execute put command with a PK that already exists, so a primary key that already exists, DynamoDB will fail because it will run this condition expression, attribute not exists. It will see, oh, the attribute exists, so the put command won't be executed. Thanks to that, it will throw an error instead of just a success and leave it for downstream systems to find the issue. And very, very, very similar to update command. Update command, in this example, we're doing it right the other way around. So with attribute exists instead of attribute not exists. Here we want to check, hey, please update the item with this primary key, but only if this condition expression is true. So only if the attribute already exists. That way, we ensure that update command won't act as an upsert. So it will only update and not insert new items. But now, developers such as Agisanya will be thinking, yeah, okay, thanks. I already knew that. What's new about condition expression, or what can I do with condition expressions? Is things like idempotency checks. Idempotency checks are used mostly in EDA architectures, so event-driven architectures, for example, where we know that by default, AWS services such as SQS, SNS, and EventBridge will deliver at least once, meaning that you could receive an event multiple times. And this is not always best, or this is something that you'd need to have in mind while developing is, hey, I need to have some type of idempotency check to make sure that I don't end up billing the same user twice for the same transaction. And for that, here's a sample code that's really run down to the least amount of code possible, but something like this, I've seen it already running in production. And as the name of the function states, it's a bad idempotency check. Why is this a bad idempotency check, and how could we improve it? It's what they are doing here is at the beginning reading an item. So they say, hey, DynamoDB, please give me that item. And then they check, hey, if the item exists and the item.status is one of the status that should not be re-executed, then we'll return an error, or we'll just return a idempotency failed. Otherwise, we will update the same item with a status set to in progress so that no other Lambda will be executing the same. Issue here is between this read and this update, there will at least be, let's say, 100 milliseconds in worst case scenario. If you don't have much logic in between, it will be 100 milliseconds. So the issue is there won't be any consistency, because if you have two Lambdas running in parallel, there will be a race condition in between to see who updates the update item condition first. So to resolve that, what we can do is use condition expressions. How do we want to implement a condition expression for idempotency checks? It would be something like this. Here, for example, we're stating, hey, please, DynamoDB, insert a record. So we'll be using a record to track idempotency of the different events, and only insert it if the following condition is met. The attribute doesn't exist. Okay, that means that it's the first time we're trying to execute or process that event, or the attribute exists, but the status is in failure, for example. That way, we know that we have idempotency, but the idempotency will also allow us to do retries. Okay, with this logic here, it will do the idempotency check that we are trying to do here, but in a single DynamoDB request and ensuring data consistency, so that only one request to DynamoDB will actually succeed and only one Lambda will be working on that single event. Another thing, and this is one that most of the developers I've spoken with haven't used it already, is return values. Most of you will already know, okay, return values, yeah, all new, all old, or none. So I don't want DynamoDB to return us anything. But another really good thing about condition expression, and something that we'll see also how to implement a business logic check. Here, it's really similar to the previous example, where we could say, hey, I'm sorry, but this is a really bad implementation. Same as before, it's also simplified from an example seen in production, where we have first the get item, then we do some business logic on the item, and then we update the stock. This example would be, for example, this example would be for a shopping page or shopping application, for example, where we want to check, hey, before we reduce the stock, let's see if the item or the product already exists, and then see if it has actually the amount the user is trying to buy. So here, they are checking if the product exists, or retrieving the product, checking if it exists, checking if it has enough stock, and then it's just reducing the amount of stock stored on DynamoDB. This would be a really bad example or bad implementation. But the difficulty here would be, hey, but I want to throw different type of errors depending on what condition failed. And for that, one of the, let's call it breakthrough moments I had working with DynamoDB is learning about this little attribute here that you can pass. Return values on condition check failure. What you're telling DynamoDB with this, and this is really a lifesaver to be used when working with DynamoDB and condition expressions, is telling DynamoDB, hey, DynamoDB, please execute this update command, but execute it only if this condition is met. So if the attribute exists and the stock is bigger than the amount I'm requesting, and if something fails, or if the condition expression fails, then please return me all old attributes, meaning that this update command request, if the condition fails, it will throw an error, a condition check failure, but that error will include the state or the attributes, how they were when the condition failed, meaning that then in the catch statement, you can check, hey, if error is not instance of conditional check failed exception, then yeah, let's just throw an error. We know it's something different. I probably messed up and provisioned DynamoDB incorrectly, or I just had some attribute mistyped here. So DynamoDB failed for any other condition. Otherwise, let's check if we have the error.item. If it doesn't exist, that means the item doesn't exist. So same check we were doing here, we can do it on the response of error.item. So we know that any exception of condition check failed exception will have the item if you have the return on condition check failure all, and that item will be marshaled, so you can unmarshal it, and then just do your business logic on the old values and see why that failed. This is for condition expressions, so I know, or at least I hope that this is something new. At least it was a breakthrough for myself. And going to retrieving data. For retrieving data, something that most people will also fail to provide, or some issues that I've seen, is using scan commands like this. Okay, I see that there are different questions from Samuel. Writes with condition expressions should be strong, right? And strong reads will only be strong if you add the attribute. So by writes means you want a strong or consistent write, you want data consistency. With reads is what I mentioned at the beginning of the consistency is not really, it's temporal consistency, meaning that you could be reading an old version of the attribute. If you don't specifically add the attribute to do a strong read, you can't be sure that the attribute is the latest version of it. It's usually 1 millisecond difference until you get that strong read. But if you don't apply it specifically on your get item query or scan, you won't get the strong or consistent reads. For retrieving data, we have scan table, which I hate, and query table or query command, which at least it's a tad better. Why do I hate scan commands? Because it's hell of expensive and usually not used correctly. If you're using scan commands in your project and you are not retrieving just a handful of objects, so if it's not a really little reference table, then someone really forgot to add the correct access patterns to the data. And similar to query command. Is query command, it's good enough. It's the only way to get attributes. The issue comes with key conditions and expressions. That's perfect. But if we try to add any condition on the actual attributes inside the document, there's where hell will break loose. But retrieving data, why I have this here is because we need to always be aware of a limitation with scan table and query table and similars before. These are things that I've seen of people trying to scan a big table and not getting all the whole table, or all the records that they are expecting. Why is this happening? Because scan table or scan command and query command have a maximum of 1 megabyte of data that can be analyzed. Okay. Why did I mention analyzed and not returned? Because here's another red flag or another thing that you need to be aware of, specifically when using conditions, so filter conditions on DynamoDB, is that DynamoDB will only use that filter on the first meg of data on the table. So if in the first meg of data inside your table, there was no attribute or no document or item that matched your filter criteria, you'll be returned null items. But that doesn't mean that there is no item in your DynamoDB matching that filter criteria. The only thing that you need to get or be aware of is maximum 1 megabyte of data being analyzed. So as Andres already mentioned, we need to implement pagination. Okay, if you're expecting, let's say, 30 items back from DynamoDB with your scan or query, and you're only getting 10, that means you forgot to implement pagination. Pagination, it's fairly simple to implement in the backend if you don't need to actually interact with the front end, but it's just taking a look at last evaluated keys. And if last evaluated keys exist, you need to send a new request to DynamoDB with the last evaluated key so that DynamoDB can start from the next item. And this would be a recursive function until you get all items or until you get the amount of items that you actually want to search for. Okay, so from this here, the only thing or the thing that you would need to be aware of is query items, or how DynamoDB applies filters is not that intuitive. If you're coming from SQL, it will only apply the filter on the first meg of data and not on the whole, or until it can return you a meg of data. Okay, so you could receive an empty item response from the first page, but you'd still need to continue pagination to fetch all the items that match your search filter criteria. So retrieving data, we've seen scan and query. Now we're going to see batch operations. What are batch operations or batch? Working with batches means just working with multiple amounts or n amount of events or items at a time. What do we want to do with batch? Is we could have an example like this, where for every key in a list of items, we would like to fetch them instead of using a scan or a query, because we know if they're not in the same mech of data, we wouldn't be getting all of them at the same time. One could think, okay, let's just add a for loop and fetch all the different items one by one. The issue here is that sequential requests are normally longer execution times. Okay, we want to change this, and we mentioned sequential requests are bad. Let's do them in parallel. Okay, so you could see a promise.all with an items.map to get all different items that you have. This will work really good if you have 10 items. If you need to retrieve, let's say, 100 or 1,000, you might find yourself in another issue or another problem, which will be parallel requests can reach maximum connection limits. Okay, so sequential requests, sequential single get item or update item or any type of request will produce longer execution time, and doing them yourself in parallel can reach a connection limit. How can we implement this, or what are you expected to do? Is implementing batch operations. DynamoDB provides two different types of batch operations. First one would be batch get. So it would be related to the previous example that we were looking at, where we want to get multiple items at once with where we already know the keys for all those items. For that, it's really simple to implement as well, where we have request items, then the name of the table, and the keys that you want to have. We can have as many items as we want, and we can have items from multiple tables at the same time. The benefit of this is you can get up to 16 megs of data in a single response, or you can request up to 100 items. Okay. Similar to batch write item, we can do the same where we get or we write multiple items to DynamoDB at once. Table name, meaning that you can write multiple items to multiple tables at the same time. And it's called batch write item, but you can also use batch write item command to delete items. So if you know the keys of the document or the item that you want to delete, you can use, instead of put request, delete request, and it will delete that item. Here, something that we need to also consider or have into consideration while working with batch write commands or batch commands in DynamoDB is also up to 26 megs of data or 25 items. Why have I written up to and or in both scenarios? Because it's really similar or very similar to the scan and queries that we were looking at before, where we had the pagination. Here we'll need something similar, because what happens if you request 100 items, but 10 of them already reach that 16 meg maximum? Or if you want to send 25 items, but the payload that you're sending for 25 items is already more than 16 megs of data. We will need to use pagination, but in this case, it's called differently. It's called unprocessed items. Here, what this means is when the response that you receive from DynamoDB when using any batch star command will contain an attribute called unprocessed items. That unprocessed items will contain the list of the items that couldn't be processed. For example, if you request 100 items, but it's mentioned before, 10 already reached the 16 meg minimum, you will need to call it again and again and again for the unprocessed items for the rest of the 90 items that you wanted. Or similar with a write request, if you want to write 25 items, but 5 items are already 16 megs, you could, or you would need to send it 5 times. So 5 times in this batch write items loop with unprocessed keys. Any questions regarding batch write items operations? No, okay. Can't see anything in the chat. So let's go to closing statements or key takeaways. What I would like, if anyone is watching this and just scroll to the end, no need to watch the rest. I just talked a lot. You can just remember those key takeaways, or you don't need to remember my whole talk. Just remember these points here, the 6 points. So first one, put and update act like upserts. Okay, DynamoDB, I'm not sure why, they decided to go with upserts always, meaning that if you don't want it to be, you will need to use condition expressions. Using condition expressions will help you reduce the amount of calls. It's a part of helping you actually implement the logic that you need or you want with the data consistency is you'll also reduce the amount of calls. For example, by instead of doing a get item and then the update item, you'll only need one update item. Or for anyone here that was not aware of the return values or return attributes on conditional check failure, they were doing an update and then the get item to get the latest version. You can just do it in a single call. Query and scan require pagination. Okay, so if you expect more than 1 meg of data to be analyzed, you need to implement pagination in your code. Full stop. There is no other way. Use batch operations to reduce execution time. Okay, as seen before, instead of doing sequential requests for get item or update item to DynamoDB, you can do them in a single batch item operation. Or this is a little cheeky hack, is we saw that query and scan can only provide 1 meg of data. But if you already know the primary keys and sorting keys of all the attributes that you want, you can just use batch get and get 16 megs of data in one request instead of calling query or scan 16 times. You can get them in a single request. So just a cheeky little hack when using batch get. And batch get and batch write require retry logic. So you will also need to check the unprocessed items to make sure that everything is processed. Okay, so we are now at the end of my presentation. Here is a little QR code in case you want to get in touch with me. You can connect with me on LinkedIn or on X, the old Twitter, to make sure or to send any questions, any feedback. Everything is appreciated. And now would also be the time to ask any questions that you might have. I might not be able to answer all of them, but I'll try my best. And also just a reminder for Akisanya, scan the QR code, send me an email, and I'll send you the credits your way.
Great stuff. I did learn something. I didn't know the return on failure, right? The condition expression, so you can return the item and then do the validations. That's great.
Yeah.
I usually just what I've done right till now is just return a generic error whenever that happens. It's like, hey, but this is
That
helpful.
was how I did it until
Yeah,
I had the realization of, oh, they can also return this. Heads up, that doesn't work with AppSync. Not sure why. AppSync team decided to not allow that feature. But if you're using the SDK, it will work.
nice. That's good. And you didn't get into the transaction part, right? Which is similar to the batch, but with slight differences. Can you tell us a little bit of those differences?
I was thinking if adding transactions or not, but it would have ended up being complex, or transaction can be a webinar in itself.
Yeah,
It's a tad complex, and also comparing to SQL is not really the same. So it's a tad
yeah,
tricky to
and it
to
costs more.
understand. Yeah. Key takeaway is they cost a double.
Yeah, stay away from scans, and if you can, stay away from transactions. Please do.
Yeah.
Any questions from the audience, viewers? You got anything you want to get out of your chest from DynamoDB? If not, we can wrap it up. Great presentation. Really appreciate it, Lorenzo. Just highlighting a few of the talks, upcoming talks. So tomorrow we're gonna have Mahmoud talking about another database, serverless database, but this is Neon, which is Postgres serverless. Alan and I did a live stream around this. It's a pretty cool database, so don't miss this one tomorrow. It's 4 a.m. my time, and checking here, it's 4 a.m. Mountain, but it will be recorded for us. But it's 11 a.m. for British summertime. Tomorrow as well, Alan and I will be doing a live stream trying out AWS App Studio to see if it truly makes enterprise grade applications. That's a service that was just announced by AWS in preview. And again, the slogan says build enterprise applications quickly. So we'll put it to the test as we usually do. That one will be tomorrow at, let me check, it's 6 a.m. Mountain, but it's 1 p.m. British summertime for everyone over there in Europe. That might be closer to your time zones. So thanks again, everybody. Thanks again, Lorenzo. Great presentation, great webinar, and happy to have you here.
Thanks a lot, Andres. Thanks everyone who participated in the chat. It was really great hosting this webinar.
Awesome. Well, we'll catch everyone later. Have a good one.